So to illustrate an application of this use of the formula for necessary sample size, let's look at example 8.2 from the textbook. And in this example, we want to estimate the mean birth weight of infants born full term to mothers who are age 19 years and under. Okay? So that's our goal. We want to estimate the population mean birth weight, and our population here is all mothers who are age 19 years and under. So the question is really, how many women age 19 years and younger must be enrolled in the study to ensure that a 95% confidence interval estimate of the mean birth weight has a margin of error not exceeding 100 grams. So we're going to enroll these women. We're going to calculate. So we're going to collect some data. We're going to calculate sample statistics, and then we're going to use those to calculate a confidence interval estimate of mu, the mean birth weight. We want to be a 95% confidence level, and we want a margin of error no bigger than 100. Okay? So stated another way, the question is, what's the value of n, the sample size, so that the margin of error is 100 at the 95% confidence level? Okay? And so to use our formula for the necessary sample size, we need an estimate of sigma, the standard deviation of the weights of all infants born to mothers age 19 years and younger. Now our problem doesn't give us any information, and so what we're going to do is use information from a different population. For infants born full term to mothers age 20 years and older, the standard deviation is 385 grams. So here we've got another population of mothers, not the same population, but in a survey of those mothers we found that the standard deviation was 385 grams. Now exactly how they found that number we won't worry about. We're just going to take that number for granted. And so we're going to take this number 385 as an estimate of sigma that we'll use in our formula for the sample size. And so now we've got all the necessary information. We just need to plug stuff into our formula. So here's our formula for the necessary sample size. Z is our critical Z value at the 95% level. It's 1.96. Sigma is 385, as we just saw. The desired margin of error was 100. We square that, we do that arithmetic, and we get about 57. So that means we would need to enroll about 57 women. Now when we calculate sample size, we always round it up, never down. Now let's make an observation here that this says that we need to enroll 57 women at the start of the study, or at least that's what it appears to say. But not every mother will deliver full term. We're only interested in this study in full term babies, and not every mother will deliver full term. And so we've got to take that into account. So in other words, we're going to enroll some people, but not all of them are going to be able to complete the study. In other words, some of them are going to attrition out. So we've got to take that into account. So let's assume that 95% will deliver full term. Now this 95% number has nothing to do with our 95% confidence level. It's just an assumption that we're making about full term births. We're assuming that 95% will deliver full term. So let's take that into account. So let's let the number n denote the number that we're actually going to enroll in the study. And so n times the percent retained, or the percent that are going to deliver full term, equals the desired sample size. So this simple formula right here takes into account kind of my attrition rate and the actual desired sample size that we just calculated up here. And so what we want to know n, that's the number to enroll. We're assuming that we're going to retain 95%, and according to our formula we have a desired sample size of about 70. And so if we do some simple algebra here to solve this for n, we divide both sides by 0.95. So n is 57 divided by 0.95, and that comes out to be about 60. And so that means we need to enroll at least 60 mothers. If we do at least 60 mothers, then according to our calculations, we're going to have at least 57 that deliver full term, and we're going to have enough to get our desired margin of error. Now, our next example, 8.3, I'm going to deal with a somewhat similar situation where we want to know a sample size, but this example is going to involve proportions as opposed to means. So an investigator wants to estimate the proportion of freshmen at his university who currently smoke cigarettes. So that's the scenario. We want to know something about a population proportion. So the question is, how many freshmen should be involved in the study to ensure that a 95% confidence interval estimate of the proportion of freshmen who smoke is within 0.05 or 5% of the true population proportion? So we're going to collect some data, we're going to calculate a sample proportion, and then we're going to use that to calculate a 95% confidence interval estimate of our population proportion. And we want a margin of error of 0.05. We're working at the 95% confidence level. The question is, what's the sample size? Well, again, note that in this situation we're trying to estimate a population proportion, not a mean. And so the formula that we just used in the previous example doesn't apply. So we need a different formula. Now, we're not going to talk at all about where this formula comes from. The book talks a little bit about it, but this is our formula for estimating the sample size, the necessary sample size when estimating a population proportion. And so here's the formula for the margin of error when calculating a confidence interval of a population proportion. If we solve that for n, we get this formula right here. So n is equal to p, where p is an estimate of the population proportion. Take that times 1 minus p, and we take that times z divided by e, where z is the critical z value corresponding to the desired confidence level, and then e is the desired margin of error, and then we square that. And again, note that in this formula the population size just doesn't come into play. As long as the population size is large relative to the sample size, the exact value of the population size doesn't matter. Again, stressing the fact that we often think that if we have a bigger population, then we need a bigger sample size, but that's not necessarily the case. All that really matters here in determining the sample size is the desired margin of error, your estimate of the population proportion, and then your critical z value, which really depends on the confidence level. The population size just doesn't matter. So now, in order to use this formula, we need an estimate of the population proportion. And so in order to do that, there are at least 3 ways that we could estimate it. We could use a sample proportion from a previous study. So we could use some information that we already know from a previous study, or maybe from a different population, kind of like what we did in the previous example. We could use knowledge of the circumstances. Maybe we could say, like, well, just based off my observations, I think about 30% of students smoke, or something to that effect. If completely unknown, we're going to use p equals 0.5. Now, why 0.5? Well, because p is somewhere between 0 and 1, and so as an estimate, we'll just take the value right in the middle, 0.5. And that's what we're going to do in this case. We don't have any information given in the problem about a previous study. We don't really give any information about knowledge of the circumstances, so we're just going to use 0.5. And so in again, to kind of summarize what information is given, we want a margin of error of 0.05. We're working at a 95% confidence level, so the critical value is 1.96, and then we'll take p to be 0.5. So now we're just going to plug stuff into our formula. Here's p times 1 minus p, z divided by e squared. We do that arithmetic, and that comes out to be about 303. So we need to survey at least 303 students. Now in this problem, we're not going to take into account attrition. We'd probably this one, attrition may not be a real factor, because this is not a longitudinal study in any sense. This is just a point study. So this means we need to go out and survey about 303 students.